You hear that? You have a problem. That is a corona problem. And I talked about lubrication. So a couple of things to think about in terms of lubrication. You can have lubrication, you can lubricate and you can improve. You can lubricate and it gets worse because the bearing was already over lubricated. Especially in the early days, if you have a program, if you're starting out on a program and you're still fighting with planned versus on condition, you can often be in a situation that you come to a bearing and you don't actually know if that bearing is under or over lubricated. We teach people in the level 1 and level 2 how to do this, but I just thought I'd pull up a couple of nice little examples for you. So here is a bearing which is about to be greased. About 10 seconds in, it will get one shot of grease, and about 10 seconds after that, it gets a second shot of grease. I don't suppose you noticed that. Now, if you put grease in to a bearing which is already over-greased, you make it worse. You don't decrease the friction, you increase the friction. This is why it's a good idea to follow the chronic over-greaser with an infrared camera, because 5 to 10 minutes after somebody's been round over-greasing their bearings, the temperatures will increase, not decrease. Because the old idea that if grease is good, more grease is better, isn't true. You can over-grease bearings. So here's an example now of a bearing that's had a shot of grease, and you can see it. You know, the shot of grease was here, round about the 10 seconds in, and after being greased, the ultrasound signal doesn't go down, it increases, it gets worse. Keeps getting worse because I've made it worse, because I've injected more grease in there and I've actually made the lubrication condition worse, not better. An important thing to also keep in mind is that lubrication is quite good at hiding bearing faults. You can sometimes be in a condition where you've improved the lubrication, and in improving the lubrication, you temporarily mask another problem. And sorry? Yes. So sometimes it's worthwhile actually going back to something that you're not quite sure about and give it another 12 hours or something and go back and take another reading. Because sometimes if it's a proper defect, then the benefit of the lubrication would have been very, very short-tempered, and shortly after, your signal will be back up again.
These noise levels are measurable, but are they repeatable?
Yes? Use the mic.
It's a clamped, repeatable signal that you can go back an hour later and compare your results.
Absolutely, yes. An hour later, a day later, a week later, as long as you go back to the same place and you can take the same reading within a dB or so, but certainly within the measurement error that you'd expect for any other mechanical measurement. But yes, absolutely, it's repeatable. The angle of holding the probe. How exact it is, we do teach people a preferred way of working to try to develop a confidence that measurements are related. Basically, We teach people to hold the probe normal to the surface. It doesn't necessarily it's not a case of vertical or horizontal, but normal to the surface. And if you're talking about a machine which would be belt-driven, for example, then if you had to pick an angle, then you'd pick an angle which would be in the direction of the belts, because this is the direction in which you've got the most force. So that's the best place to be. You also have to take things into account in terms of construction of the machine and filtering of the signal caused by changes in materials, changes in densities, changes associated with having gaskets in place. So if I'm working on a gearbox, I'm going to be on this side of the gasket rather than on that side of the gasket, because my signal is going to be attenuated through the gasket. But that's all part of the training. Yes, that would be the next thing. It would be painted markers, or one that I find very useful is just stick-on washers. Very inexpensive. You know, you buy a bag of mudguard washers or something, and you pay $10 for 500 washers, and you just stick these on, and you take your reading where they're stuck on. But where you stick them on is important. You don't just have somebody randomly sticking them on all over the place. You have them put on in precisely the right place. Right? When we start talking about doing reporting on machinery, be creative. Put some creativity into that report. If you want to get hold of a machine, to bring that machine down, you need to present a good argument. And again, I remind you that spewing out 20 pages of numbers is not a good argument. That's just 20 pages of useless numbers. Some plants I work in, they have a category system. 1, 2, 3, 4. 1, 2, 3. Everything as it deteriorates is in a category. In fact, one plant that I work in, they have a weekly meeting. And part of the weekly meeting, which actually is at executive board level, weekly meeting, includes asset health. And it works on a category 1, 2, 3, 4. Category 3, this is desperately in need of change. Category 4, how on earth is this still running? Right? Something that's in category 4 and fails, all hell breaks loose. Why was this allowed to happen? At board level, why was this allowed to happen? Very useful. Very, very useful. Great way of making people improve. You know, because if you can't help people improve, you sometimes have to make them. But improve, we will do, because we have to. Lovely little story, this, about getting the message across. This was a true story. I was out on a customer site, taking these readings, and I'd produced a little report, single-page report, and a Word document, sent it through to the customer, and I'm on the phone to him on Monday morning. Took this on Saturday, and you've got a problem on that bearing. And he's going, oh, right, yeah. Look, here's the vibration spectra, and you can see how I've shown the history of the last 6 readings, and it's so much worse now than it ever was before. Oh, right, yeah. Oh, yeah. And here's a time signal, and it's got this signal, it's got this event that's taking place now once per revolution, and it's 4 times higher than any of the other ones we've ever seen on the plant. Ooh. Maybe we need to do something about that. I said, you see that speaker there? Yeah. Well, can you just click on it for me? You know what he said? You didn't tell me it was that bad. Oh, yes, I did. It's just hieroglyphics. The people around the room, I could see the people around the room who understood vibration, because they were all sagely nodding. as I was showing these things, and everybody else was looking as blank as my guy was on the end of the phone. It's just hieroglyphics. It has no meaning. But you put the sound file in there, and people, oh, right, yes. Oh, well, we need to do something about that. Slow speed bearings is a huge problem, but not for ultrasound. Slow speed bearings is very, very simple and straightforward for ultrasound. If, for example, I was trying to do a reading on something that was rotating at 14 RPM, then to do it with vibration, I would need a 21-minute measurement with a 500 millivolt per G sensor. And this is why most people get it wrong, because they don't do it properly. It is doable, but they just get it wrong. Now, what happens if the machine isn't stable for 21 minutes? Very difficult to do anything then. But with ultrasound, a minute of data on that slow speed machine is still a luxury. So here, for example, is an example of a hoist bearing. This hoist, critical piece of machinery in a coal mine, only runs for 30 seconds and only runs at 14 RPM. Very, very difficult to throw vibration at this one. But ultrasound, not a problem. There's the time signal. There's an expanded version of the time signal. And for those of you who don't read time signals, there's the bearing going through the load zone, the defect. All right? So I've got 25 seconds worth of data there, and I can look at that data with my ultrasound system, and I can look at the time signal of that data with my ultrasound system, and I can tie it in with my vibration data insofar as looking at the vibration bearing defect frequencies. The bearing defect frequencies are the same. It doesn't matter how I measure it. And so then if I look here and expand the signal, I can actually identify, in this particular case, an inner race defect. And there's the proof. So there's an inner race defect on a bearing rotating at 14 RPM for 30 seconds only. How else am I going to do this if I don't use ultrasound? I wanted to finish off with some case histories for you. This will be, I hope, the basis of a future presentation that I would like to think we might be able to do at Solutions 2.0 later on this year. So I'm just pulling together some case histories from various different areas. All of this is ultrasound. All of this is using exactly what we've talked about, and the thought process is in exactly the way that we've just talked about them. And these are some very, very nice real-life customer savings. So this particular one was well published, and this particular company last year won the ultrasound, mobile ultrasound company of the year here at Solutions 2.0. Measuring leaks, identifying leaks on the air intake system on large diesel engines used in open cast mining applications. So they identified dusting in the oil. So primary test mode of their condition-based maintenance was oil analysis. This identified a problem. The problem turned out to be identifiable with ultrasound as leakage, as air bypassing the filters through tiny little holes in the ducting. Find those tiny little holes using ultrasound, weld them up, repair them. One of these engines, by the way, is $500,000. $500,000. So last year they posted savings in excess of $2 million just in that one application. On top of that, they used the same system for doing tightness testing inside the driver's cab to ensure that there's a clean and healthy working environment for the driver. There's no dust intake. And it's also used in all sorts of other areas on that in that application as well. So that's a really nice little tightness testing example. This is a beautiful story that came through quite recently about the benefit of using air leaks. And you can see it there. I was talking to Bill this morning. He told me the reason he was able to justify the purchase of his equipment was he had documented from 2009 to 2010 280 air leaks. And in fixing those air leaks had shown a saving of $165,000. Yeah. And that saving of $165,000 was his justification for buying all his equipment, because he'd created his own budget. What was the first thing I talked about? Vested interests. And how do I get back the money? You know, maintenance is finding the leaks. Maintenance is fixing the leaks. Maintenance doesn't get the money. Maintenance got the money.
Because of an outside company came in and said, I'll save you $165,000 in 2 years. Give me 25% of the savings. The management would probably say, go for it.
Yeah.
I mean, you know.
Yeah.
So it's only right that maintenance gets some share of that benefit.
Here's a vacuum application. Again, a very well documented story now from a pulp and paper mill, where we were using ultrasound on a pipe that was insulated, using a contact probe, taking a measurement on the outside jacketed insulation, finding massive vacuum leaks inside these pipes. So again, what was done is you can see the area was all mapped out, readings were taken in various places, and you can see very clearly there where there's the problem. Stripping it away, finding and fixing it. The report that came back, vacuum improvements on the evaporators resulted in the best solids throughput tons per day we've achieved in the recent past. The best. If you're trying to be profitable, if you're trying to be competitive, all these little incremental savings make a huge difference to your business. A huge difference. Transformers out and outages. I mentioned the cleaning application, which saved a fortune. On-condition cleaning is growing in popularity for that kind of application. I have another case history. Company in South Africa who are looking after 75 transformers using ultrasound, doing routine measurements in survey mode every month around the outside of a transformer as an early stage detection system for internal arcing. They have dissolved gas analysis on their oil, but that's a lagging indicator. It's not a leading indicator. You know, if you have a DGA system, it tells you that you have the result of the problem. But if you have ultrasound, it's telling you have the problem, which will then be corroborated by evidence in the dissolved gas analysis. So they're just going out on a routine monthly basis and just taking a series of readings around the outside of the transformer in a survey mode and bringing that data back and analyzing it. Very simple. Saving millions. Valve leakage. I showed you that curve earlier on of the valve. That particular company was spending over $2 million a year inspecting that particular valve, that particular type of valve. They were spending $2 million versus a one-off cost of 20 grand to inspect them online, live, in situ, in use. It's a no-brainer. Lubrication improvements. This is an interesting one. I think it is anyway. This is a coal mine in South Africa. And so this data was given to me September last year. So we implemented a program of on-condition lubrication. And after 9 months of operating this program of on-condition lubrication, they had 3 very interesting facts that they could report to me, which are there. The first, real shocker, only 10% of the bearings needed greasing. So in all previous years, we've greased 100% of them. But actually only 10% of them last year needed to be greased. As a result of that, our grease consumption was reduced by 95%. And yet we were still able to maintain our 100% zero unplanned bearing failure system. So, no increases in bearing failures, no increases in maintenance work, but a decrease in grease consumption of 95% and only 10% of the bearings needed grease. In that particular case, it's a saving of hundreds of thousands of dollars. In your own plants, how much would it be? Vast, vast amounts of money. A nice case history of throwing everything at the problem. I mentioned this briefly before. This was a board plant, and I helped them implement vibration and ultrasound and thermography. And after about 6 months, started to get the knocks on the door. And the first person through the door was the lubricant supplier. Who are you buying your grease from? Well, you. Yeah, but you're not buying anywhere near as much. Yeah, I know. Now, if you've ever seen a corrugator, these are very, very high temperature machines, 150, 200 centigrade, using very high temperature greases, very expensive greases. We're talking 10 years ago, we were talking a 20 kilo tub of grease was about $1,500, 10 years ago. So to see a dramatic fall off in sales of that kind of grease is really hurting the salesman. Then the bearing supplier comes through the door and says, where are you buying your bearings from? Well, you. But you're not buying anywhere near as many now. Sorry. But we're not having the defects that we had. And then finally we get the electric motor rewind company coming through the door saying, who's rewinding your motors for you? Well, you are. But we've not done one for 3 months. Sorry. We've not had a failure. So these are tangible savings there that come as byproducts, if you like, but they're big, big savings. Case history about too busy with vibration. I'm too busy with vibration. I don't know how many times I hear this one. I'm too busy doing my vibration. One poor customer I saw the other week were taking 5,000 readings a month with their vibration system. They didn't have time to breathe. It's 5,000 readings a month between 2 guys. And everybody falls back on the ISO standard. This is the crutch that everybody eventually falls back on. And there are some things in that that are really quite interesting. Firstly, the lowest category is 20 horsepower. Or should we say up to 20 horsepower. Well, somebody I think who was even given a presentation here yesterday was saying not rolling out condition monitoring on machinery that you weren't going to repair unless it was critical, was the caveat, unless it was critical. But lots of people don't have that hook on the end. They just say things like, we don't do anything that's less than 30 horse. Okay, fair enough. The other interesting thing about this, which is very hard to see when you look at the data in the inches per second, but much, much easier to see when you look at the data in the millimeters per second, is 0.28 to 0.75. That's 2.5 times increase, and it's still okay. That's quite a big spread, isn't it? of okay? I think that's a very big spread of okay. But this is the ISO standard, so it must be right. Okay. Here's an example of too busy with vibration. This particular company applied vibration only to motors above 30 horsepower. But their process was very, very sensitive to climate control. And the motors in their compressors were only 15 horsepower. So they weren't checked by vibration analysis. Fortunately, they were checked using ultrasound. And it's a really good job, because here's a case of a motor that failed. And they saved $6,000 just in saving the motor. That's without considering all the horror that would have been associated with losing the temperature and humidity control in the process, which would have meant throwing product away, stopping the process, goodness knows how much cost. But this was a critical piece of equipment, but it was under 30 horsepower, so it wasn't dealt with vibration. And there's our bearing, and very short signal there, but definitely not healthy, eh? Would you all agree? Definitely not healthy. And here you can see, I think very interestingly, you've actually got damage not just on one race, but you've actually got damage on both races. Very, very simple success there. For a lot of people who are too busy with vibration, I offer this filtration. First question, what's actually the most important question in the whole of predictive maintenance? And I would say to you, it's that, is it okay? Why are you out taking all those readings? What are you trying to do? What are you trying to prove? Ultimately, you're trying to give an answer to that very simple question. Is it okay? Yes? No? So, do I always need vibration to answer that question? No, I don't. I can answer that question quite frequently using ultrasound. So, is it okay? Yes. Well, what else is there to do? You're going to write a report on it now? You're going to waste more resources on it? It's okay. Leave it alone. Move on. It's okay. No, it's not okay. So what's the next question? Is it lubrication? Well, what's the best tool for that? Ultrasound. Did I fix it? Yes? No? So when I get to this point here, now, I have a problem, and it's not lubrication. You put this in as a front-end filter to your vibration program, and see how your vibration program changes. One customer of mine in a coal mine, before implementing this, 25% of their plant was run to failure. Not by choice, but because they weren't allowed any more people. They already had 12. They already had 12 people out taking vibration data, thermal imaging data, and all the rest of it. They had 12 people, and they weren't being allowed any more. They implemented this program. Not only did it give them 100% plant coverage, but it also gave them an opportunity to use people for improvement programs. Remember improvement? And I'll give you a very nice example of one of the things that they did on their improvement program. Anybody got any big gearboxes? Big gearboxes? You know with big gearboxes that by the time they're 6 months old, they become priceless, don't you? Because you can't get spares for them anymore. And you might be on a 6-month or a 2-year lead time on it. Well, these people had time now because they were in control. So one of the things that they did was they set up a program to test and qualify the oils that they put in their gearboxes using ultrasound. So, how many oils can I put in that gearbox? Well, every salesman had an oil that could go in the gearbox. Everybody wanted that contract. How do you normally choose oils? You probably don't normally choose oils. It's probably somebody in the purchasing department, isn't it? Or maybe it's done on a golf course. Edit that out, won't you, Terry? It's done on a golf course, but it's not done on an engineering basis, is it? More often as not. We have a corporate agreement with, yeah, but that oil's no good for my gearbox. We have a corporate agreement with. So what they did in this case was they said, okay, we're going to have 5 contestants, and we're going to test each gearbox live, in situ. Flush out the gearbox, contestant number 1. Running in situ, measuring with my ultrasound. What am I measuring? I'm measuring the individual tooth-on-tooth friction. So as the teeth rub as they go past the friction, that's what I'm listening to with my ultrasound system. Especially if I capture a time signal, I can actually see the individual teeth meshing. And I can see the individual friction associated with each tooth mesh. So, having freed up the people to do the improvement program, they then applied that improvement, those people, to this particular case. Now, having gone through 5 oils, all of which supposedly could work, the oil that's in the gearbox is the oil which gives them the lowest level of friction. By measurement, not by salesman. Is that useful? I think so. Is that going to save them some money? Oh yes, that's going to save them an awful lot of money because they're reducing the wear on their priceless gear teeth. So, conclusions. Sir, how much difference was there between the good and the bad? I don't have that data to hand. I'm hoping that this final part of the presentation, as I said earlier on, I'm hoping that I've proposed this final case history part of the presentation to be a presentation for solutions in Florida later this year. And so that data will be part of that. I don't have it right now. But it was significant. I know that much. It wasn't subtle. It's faster to do it. It's faster to actually physically do it. But also, it's faster for a variety of reasons. So firstly, we're not worried about the directionality. We're not doing horizontals and verticals and axials and things like that. We're only taking a single reading. So the amount of time it takes to take the reading is also very, very short. This gives us much faster coverage as well. So everything is quicker. The analysis time is negligible because you've got your headphones on. It's a little bit like using infrared. You know, you're out taking data with your infrared. You're diagnosing as you're going along. You know where the problems are as you're going along. With ultrasound, the same. You're there with your headset on. You know where the problems are as you're going around. But you have to be an experienced vibration analyst, an experienced vibration guy taking data to actually know as you're going around with vibration that this is a problem. So more often as not, I find in lots of plants, you have one person that's capturing vibration data and then somebody else is spending half a day analyzing it. It's not instantaneous. And when you add all that time up and add all that manpower up, this is a huge saving in time. Yeah? So, what are you waiting for? I can do routine inspections in so many areas. You know, steam, vacuum, valves, steam traps, air leaks, lubrication, all these areas. You can roll it out. There's help available if you need help to roll it out, but you can roll it out. This isn't science fiction. This is reality. And I've given you some of the numbers about how much people have already saved. It doesn't have to be complicated. It can be easy. And how many zeros go on the end of how much you can save? Tens, hundreds, thousands, millions? It's there to be saved. You've been a very nice audience. I thank you very much indeed.